Good afternoon, everyone. Welcome to the 10th class of reagents in organic synthesis. In this class, I am going to discuss about gold-based reagents and iron and cobalt-based reagents. So first, I am going to discuss about activation of alkynes by gold. So alkynes has a character. So this is the pi bond which is binding with any kind of pi bond activating reagents such as golds. So here, because of the sigma donor property of the pi bond and pi acceptor or antibonding pi star orbital, so this the pi bond can donate and accept electron from the gold complex. So here, this is the sigma donor interaction of gold complex. So this is the sigma donor. So the DJ star orbital of the gold accepting, and this is the pi of bonding orbital of the pi bond which is donating. So this is the donation, and this is the DJ star orbital of gold which is accepting. And further, this is the sigma donor. Further from the AU gold complex. This is the pi star orbital of the alkyne. So this is a pi star orbital. So that can be also accepted. So by this way, so this is the interaction. So this the pi bond is activated by the gold by the sigma donor and pi acceptor property. So if by the activation of the gold, this bond is now labile. So this is now labile. Now in presence of any nucleophile, this can be attacked and form this kind of gold complex. So this is the gold complex in presence of nucleophile happens. So further, if we use proton, then proto deoration happen and we will get this kind of species. So there is a two possibility, either gold nucleophile attack in this way or here this way. So if it is attacked this way, this is Markovnikov, and this is anti-Markovnikov. Anti-Markovnikov. So this is the Markovnikov pathway. So our pi bonding carbocation stability, carbocation stability matters. Or this is the not carbocation stability doesn't matter. So this is the mechanism. So first activation of the pi bond happen through the pi gold. So this is the pi complex which is forming. Now in presence of nucleophile, it is attacking either this way or this way, depends on the Markovnikov or anti-Markovnikov ways. So further, so this there is possibly in presence of proto deoration happen, and we are getting this alkene from alkyne. So if we consider about some examples, so in these cases, this is the example. This is of alkyne, and this is acid moiety are there, alkyne moiety are there, and alkene moiety are there. So first, as the pi bond character of alkyne is more than the alkene, so this pi bond is first activated by the gold. And now in presence of nucleophile, such as this acid, there's a two possibility. If it is go like this way, this is 5-exo dig, or it is go like this way. So this is 6 endo dig. So it is go via 5-exodic, we will get the 5-member product, or if it go via 6-exodic, we will get the 6-member product. So this is the mechanism. First activation of the gold, activation of the pi bond by the gold, and then the nucleophile attack. And further protodeoration happen, giving this product. So this is also an example. So what happened here? Here also gold have activate the pi bond, and then this ketone attack 1, 2, 3, 4, 5. 5 exodic, 5 endodic, 5 endodic pathway, and we'll get this compound. Now there is a possibility of 4 pi plus 2 pi electrocyclization. So what happened? The oxygen attack like this way, this will go like this way, and this will attack this way. So this will give this compound. Now further what happened as this is gold is positive, partially positive, this is partially negative. So this bond go like this way, this will come here, this will go this way, and it will grow, and will get this product. So now I am discussing about iron-based reagents. So basically in the gold, when just activation of pi bond I have discussed, this is the most common activation or reaction happen in gold chemistry. Now I am going to discuss about iron-based reagent. So first, in iron-based reagent, I am going to discuss about Coleman's reagents. So this is Na2, Fe, CO, whole 4. So this is the Coleman's reagent. So what happened in Coleman's reagent? Any kind of alkyl halide or alkyl halide in presence of iron gold complex, iron or Coleman's reagent give this ketone. So alkyl halide to ketone. So first, if it is giving aldehyde, so then we will use no electrophile here. Acetic acid has been used. If we use any kind of electrophile, then it will give ketone. So what happened in this case is first reaction of the oxidative addition of the iron and RX bond happen and will give this compound, and then insertion, this carbonyl insertion happen. This is the insertion. This is oxidative addition. Now, if we use any kind of acid H plus source, then we'll get the aldehyde. Now, if we'll use another alkyl halide, such as we'll use R1 halide, so then we'll get, after deductive elimination, we'll get this alkyl halide. This is the ketone. This ketone will get. Iron also used as a Lewis acid, so it can activate any alcohol. So if we use Fe3 plus iron chloride in presence of alkyne and alcohol, so we'll get this compound. So first activation happen, we generate the carbocation, and further reaction of this giving this ketone. So this I'm going to discuss about the mechanism. So first, Lewis acid behavior of the iron. So this is iron in class 3 oxidation state. So first activation happen, and one molecule of, so this is the dimeric form which can also possible. So this will react and leave the alcohol as a water and FeCl3, so giving this ether. Further, FeCl3 activate this oxygen. So this is oxophilic. So iron reacts with the oxophilic oxygen, and then this alkyne react and liberate this, giving this fruit, and further addition of water will give this one, and after tautomerization giving this product. So this Next, I'm discuss about cobalt-based reagent. First, I'm discuss about acylation reaction. So, cobalt bromide, which is plus two oxidation state, in presence of zinc and any kind of ester or acyl chloride. So, RCOCl, acyl chloride or anhydride, such as RCOOCOR, can react with the halide, aryl halide, and give this acylated product. So here CuR, which are used. So what is the mechanism? So cobalt 2 in presence of zinc reduced to cobalt 1, and then oxidative addition of this alkyl halide, sorry, acyl chloride or acyl anhydride, oxidative addition giving this product. Then aryl bromide, which react with the zinc and give what form this aryl zinc complex. Then addition, further reductive elimination, giving this acylated product. So any kind of alkyl halide such as bromobenzene plus benzoic anhydride in presence of cobalt 2, zinc, giving this acylated product. So this is the another reaction of cobalt, which is called Volhard reaction. So 2 plus 2 plus 2 cycloaddition reaction happens. So first, any kind of alkyl under cobalt cyclopentadiene complex from this activated product, another molecule of alkyl further added and will form this one. Then there is a possibility of 2 plus 2 cycloaddition reaction. So 2 plus 2 reaction. So this will go, and this will go. So this giving this cyclopentene cobalt complex. Now if we use another alkyne into which has oxidative addition of the cobalt and then 4 plus 2 or insertion giving this product or this product, and after elimination this way, like this will go away, this will go, and it will then giving this benzene ring. So that's 2 plus 2 plus 2. So one this, it will react with another 2 this, and it will react with another 2 this, giving the 6-member ring. So this is the Nicholas reaction. So here propargyl is alcohol, propargyl alcohol, propargyl ether you can say, under cobalt, Lewis acid and nucleophile from nucleophile added product. What happened first? Cobalt after carbonyl in presence of alkyne from this product, this cluster. This cluster will come. So alkyne is somewhat protected with the cobalt complex. So now in presence of Lewis acid, it will activate the oxygen lone pair react with the Lewis acid and form this carbocation. So now in this carbocation, in presence of any kind of nucleophile, react and form this, and further oxidative cleavage of this carbonyl, cobalt carbonyl, giving the alkyne back. Now I'm going to discuss about the Poisson reaction. This is also very important reaction. So in presence of alkyl plus alkene, in presence of cobalt carbonyl giving cyclopentadiene, cyclopentinone, this one, cyclopentinone. So this can be intermolecular or intermolecular. So terminal or internal alkyl, monodi or trisubstituted alkene, giving this product. So this can be intermolecular or intramolecular. So what is the mechanism? First, activation of the alkyne by the cobalt. This 8 electron cluster. Then loss of cobalt, giving the 6 electron complex. Then add oxidative addition of the alkene to the cobalt complex, giving this 18 electron system. So this happen through like this way. This will go and this will react. So this giving this compound. Then further this insertion of the CO molecule. So insertion of the CO molecule and then reductive elimination or giving this cyclopentanone. This is the mechanism. Now I'm going to discuss about the problem solving class. So first question is this one. So this is the gold chemistry. So gold reagent in presence of so now this ketone in presence of amine from imine. So so this is minus water giving this imine. Now in presence of gold, this will activate it. Now this nitrogen has lone pair, so this will react by this way. So Markovnikov fashion, Markovnikov way, 5-exo decyclization. This will form a 5-member. There will be one methyl. CH3, CH2 pH, gold, and here one COCH3. Then after proto-deoration, proto-deoration giving this one. Then protonization happens, so it will go like this way, and this proton also go like this way, giving this proton. CH3, COCH3, this is methyl. So this proton giving this methyl, and this will elimination giving this. So the last one is the right answer. pH CH2 pH is benzene, so we can write CH2 pH as benzene group BN. Next question is also activation. So this is alene. So this can also has 5 density, so it will also react with the gold complex. And now the amine react by this way. So this will 6 endo cyclization. giving this six member ring, NH2 plus, seal with the CH2CH, CH2CH2, gold, methyl, benzyl, and butyl. Now protodeoration happen. Protodeoration giving this N butyl, methyl. Now further this will quenched. This is plus, so this is after proton elimination giving this product. So this one light and C. Now which is the incorrect about Coleman's reagent? So the chemical formula of Coleman's reagent is Na2 FeCO whole core. So this is incorrect. Incorrect. Two alkyl halides upon ketone via successive oxidative addition. Yes. First Rx in presence of Coleman's reagent from this R CO FeCO whole 3. After then another giving R prime X giving this ketone. So this is right, correct. So beta hydride elimination, no beta hydride elimination happen, incorrect. Reaction is concerted, yes, this is also correct. So the incorrect statement is C and A, only A and C. Okay. So predict the major product. So this is Kosen-Khan reaction. So first alkyne in presence of cobalt octatriene, this plus cobalt octacarbonyl from cobalt. Cobalt, cobalt. This one. Then ox this will that oxidative addition of the carbonate with the alkene with the cobalt center happen. Then insertion happen. So so there is a possibility of reaction with this side. So this is unsymmetrical. So there is a possibility of reaction of alkene in this side or this side. So the reaction happen to less hindered side. Less hindered side. So this is the less hindered. Less hindered. That's why reaction happen to this side. So insertion happen. CO. Then carbonyl insertion. Carbonyl insertion. What will give after carbonyl insertion? After carbonyl insertion, we'll get this one. Cobalt, cobalt, pH. Okay. This one will get. Then what happened? This will broke. This this is called like this way. So this is from the cyclopentanol. This, this, CO. Now giving this cyclopentanol. I think this will. I may be wrong. This one. This one will come after that. Okay. Then this will go. And this will go. This will get the cyclopentanol. The right answer will this one. So this is happened through reaction of this side, less in that side, the less in that side reaction happen and this will react with the carbonyl and this will yeah. This is give the cyclopentanol. This one. So this is the acylation reaction. So this in presence of cobalt, bromide plus zinc, which will form cobalt ox single one complex, then oxidative addition COPH, COPH, then PHPR adapt on the cobalt COPH, PHBR. Then reductive elimination of these two, reductive elimination. Get me? COPH. So this one. So this is the sixth question is the iron one. and now what happened? The nitrogen lone pair react with the iron 3. So the activation happened. So now after this activation, this top pi bond react and leave one chloride. So it will form CH NCl. So this is the S double bond. So this is nothing but stosyl group. So I am writing the stosyl carbocation. Now nitrogen lone pair react. This is the aziridine which will form plus this. Now there is a possible liberation of the Cl minus which is liberated. We will react with this one and utilize this which form this aziridine complex. Now one molecule of Cl minus further react with this one. So this is that mode substituted or Markovnikov reaction. Carbocation stability is mode. So giving this will react and aziridine ring will break. NTS minus Cl. And after proton extraction, it will generate this one. Cl, NHTS, P. So the right answer would be the first one. So this is the polar cyclomerization reaction. So what happened in this polar cyclomerization reaction? So cobalt first form this 2 plus 2 plus 2 cyclomerization reaction. This is 2 plus 2 plus 2. So one alkyne in presence of cobalt undergo first 2 plus 2 cycloaddition reaction and from this cyclopentene complex this this further react with another kind of alkyne and from cyclobenzene ring. So what is dicobalt octacarbonyl converted into eta 5 cyclopentyl diene dicarbonyl cobalt, which is the catalyst. Okay, this is the right answer. It is correct. First, eta 5 dicyclopentadienyl cobalt carbonyl form. This one cobalt carbonyl. Yes, cobalt carbonyl form. Then he will the oxidation state of cobalt in eta 5 cyclopentadiene plus 2. Yes, is plus 2. The reaction. This is also correct. The reaction is unique. Uh, So the reaction is unique as it brings about the formation of benzene ring. So this is not right. There are several reactions which form 2 plus 2 to plus 2 cycloaddition reaction. This is happening in cobalt, ruthenium, rhodium also react via this way from 2 plus 2 cycloaddition reaction. So via one step 2 plus 2 cycloaddition. So this is incorrect. By one step 2 plus 2 cycloaddition reactor, the dialkyne will form monoalkyl. This is right. So A, B, and D are the correct. This one, which is an incorrect point in the Nicholas reaction. So Nicholas reaction is basically the any kind of propyl ether. This in presence of carbonyl, cobalt octacarbonyl, and nucleophile and an oxidant form this one. So I've discussed here this one. So here first what happened in that cases, the first alkyne will react with the cobalt octacarbonyl, and from this cluster the alkyne is protected by a cobalt complexes, and then in presence of Lewis acid, so first happen this in presence of cobalt, the alkyne is from this cluster cobalt, cobalt, carbonyl, carbonyl. And now in presence of Lewis acid it form the carbocation, and then nucleophile will react. In Nicholas reaction, iron is used. No, incorrect. Cobalt has used. So Nicholas reaction, cobalt is used. Yes, correct. Oxidative demetallation gives the desired alkylated product. Yes, after the alkyne is protected by the cobalt carbonyl, then this is clipped. This cobalt is clipped by oxidizing reagent. So back to the alkyne. This is also correct. It is named after Nicholas. Yes, this is also correct. So the incorrect answer is only A. Predict the major product of this reaction. So in these cases, cobalt octacarbonyl in presence of hydrogen from the active catalyst HCO. This is the active catalyst. After hydrogenation, it will pop. Now this catalyst will react with the alkene. So now in presence of alkene, so this catalyst will react. So there is a possibility, two possibility, either Markovnikov or anti-Markovnikov. So this it is react with the Markovnikov fashion. So I'm writing like this. So, Markovnikov fashion means carbocation stability. So hydrogen will react here and this will go. So this is react with Markovnikov. So this CH3 and this will be cobalt CO whole code. Or it will react with anti-Markovnikov. So then hydrogen will react with this side and this cobalt will react this side. Now except insertion of the carbonyl happen. So CH3 insertion happen. CO cobalt. Now in presence of hydrogen, it will fit further formilated. Will give. this one. So this is the Markovnikov root, and this anti-Markovnikov root, it will give CH3, CH3 for my group here. Now, in these cases, PVC has been used. So, in presence of this kind of phosphine or bulky reagent, Markovnikov pathway is the favored pathway. So, by this way, the ligand whatever the alkene is reacting with the hydrogen that is favored through phosphine or Markovnikov pathway. So, we'll get this one is the major product. So, the formylation happen on the Markovnikov pathway. This is the Markovnikov, which is favored by the tributyl phosphine. Major product of the reaction. So here also first activation of the alkyne by gold, and then this epoxide oxygen will react. So this is give 5 endo decyclization happen. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. It's the gold. So it will react. This will go. Uh, so killing this one. First activation, then nucleophile react here, it will go this way and broke this one. From this 5-member ring, see this methyl, this will be from the carbocation. This is the CH2 whole 4 OH, and this is the gold. Now after protodeoration, it will give the D gold complex, CH3, then this is CH2 whole 4 OH. Next, proton elimination giving uranidine, CH3, CH2, 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 OH. So the right answer this one. This is the 10 question which I have today. If you have any question, you can ask me. So if I summarize this, first I have discussed about the gold activation of the alkyne. So the pi bond of the pi bond of alkyne react with the gold complex. So by or the gold pi star orbital or the gold complex reaction happen through the gold sigma donation. Then this is the activation, and after the activation, the nucleophile react through Markovnikov way or anti-Markovnikov way, depends on the substituents. So these are some examples. So this is the iron may Coleman's reagent, two alkyl halide reagent, carbonization happen. The fluid acidic behavior also observed in presence of gold, iron. This is the acylation reaction. So in presence of cobalt, zinc, and alkyl halide and acylating reagent, we can observe the acylated product. So this is the polar 2 plus 2 plus 2 cyclization reaction of the cobalt in presence of alkyne, which get benzene ring. The Nicholas reaction propargyl ether in presence of nucleophile and cobalt octocarbonate, giving this nucleophile attack or alkylated or arylated product. This is the Poisson reaction which generates the cyclopentanone in presence of alkyne, alkene, and cobalt octocarbonate. These are some question. So if you have any question, you can ask. Otherwise, I'll close this. Bye bye.